Hello and welcome to another linear integrated circuit class. In the previous class, we focused on ideal op amps and how we can solve ideal op amp problems. This is just a quick review. I'm going to do a quick review today, and I will continue with ideal op amps and solve different ideal op amp problems. Most of our focus today would be solving practice problems. Then I will go through difference amplifiers and summing amplifiers and so on. So we learned about the op amp ideal model, ideal op amp characteristics like having infinite input resistance, input current of 0, 0 output resistance, and infinite open loop gain. But the most important properties of an op amp, ideal op amp, is that the input positive voltage is always equal to the input negative voltage, or the inverting input is always equal to non-inverting input. And also the input current is always equal to 0 because the input resistance is infinite. We went through the power supply and how the power supply of an ideal op amp is connected and how the inputs are also connected. Again, the negative input is called the inverting input. The positive input is called the non-inverting input. The power supply, positive power supply, is usually connected to a positive DC power supply. The negative of the power supply is connected to another DC power supply, and this would be our common ground. And the negative power supply is connected to the negative supply of the circuit. For the ideal op amp, the slew rate is infinite, meaning the instant you would have an instant response, and the output is usually 1 to 2 volts less than the power supply outputs. We went through different configurations of amplifiers, such as non-inverting amplifier and also inverting amplifier. Today we will solve a couple of problems on non-inverting amplifiers and inverting amplifiers. We solved also a few problems, but today we will solve more problems on non-inverting and inverting amplifiers. For a non-inverting amplifier, the gain V out over V in would be 1 plus R2 over R1. In a non-inverting amplifier, the input voltage is connected to the positive input or the non-inverting input, and the negative input is usually connected to the ground. So if in an operational amplifier, the input is given to the positive input, it's a non-inverting amplifier. And the gain would be 1 plus R2 over R1. For an inverting amplifier, the input voltage is connected to the negative input of the op amp, and the positive would be connected to the ground. For a inverting amplifier, the gain would be negative. V out over V in would be negative R2 over R1. We went through a inverting amplifier as well. Let's solve a couple of problems on inverting and non-inverting amplifiers first. Then we will go to different types of amplifiers. We'll continue with different types of amplifiers. So the first question that we have This is negative, and this is positive, connected to the ground. R1 and R2. So R1 is a fixed resistor with a resistance of 250 ohms. We want to find, and Vn, or V source, I can call it, is equal to 6 sine of 4t. So we have an AC input, and the input is 6 sine of 4t. We want to find the output when R2 is equal to, let's say, 3.2 kilo ohms. So R2 is 3.2 kilo ohms. R1 is 250 ohms. Vn is 6 sine of 4t, or make it 0.6. 0.6 would make a large output there. Put it in saturation. So put 0.6 sine of 4t. We want to find the output voltage. I'm going to give you 5 minutes to solve it. And the first person to solve it gets an extra point on the next homework. So Has anyone solved it?
Negative 0.534.
0.534. No. But pretty close. Has anyone else? I'll give you a few minutes.
5.72.
Again,
0.536.
no. Okay. So first question, what type of amplifier is this? Is it a non-inverting or an inverting amplifier? Inverting amplifier. So for an inverting amplifier, V out over Vn is equal to negative R2 over R1. In other words, if you want to find V out would be equal to negative R2 over R1 times Vn. Am I correct? Okay. Vn is equal to 0.6 sine of 4t. If we have an AC signal, V of an AC signal is actually A sine or cosine, doesn't matter, cosine of omega t or sine of omega t, which I can change it to the sine. So the thing is, we don't care about the second part is actually the imaginary part. It's our frequency. And the op amp doesn't alter the frequency at all. So we are just interested in the amplitude A, which here the amplitude is actually the maximum voltage. So this, it only multiplies into the amplitude. So therefore, V out would be equal to negative 3.2 kilo ohm, which is 3,200 ohms over 250 times 0.6 sine of 4t. So 3,200 over 250 gives us negative 12.8, and 12.8 times 0.6 gives us negative 7.68 sine of 4t. The t doesn't change, nothing changes. You just multiply it. So what you're gonna have is you have this in the input, and the amplitude here is 0.6. It's between 6 and 0.6 and negative 0.6. And in the output, what you're gonna have is you're gonna have a reversed, because it's an inverting. So whenever this is positive, output would be negative, and negative will go to positive. And the amplitude here would be 7.68. It's gonna go to 7.6 with the same frequency. So T frequency remains the same. Let's solve another one. So R1 is 2.6K, R2 is 12.4K. We want to calculate V out. I'll give you again a few minutes. And V in is 3.6 million. I think, yeah, it's. So first question is, what type of amplifier is this? Because the input is connected to the positive, it's a non-inverting amplifier. And for a non-inverting amplifier, V out over Vn would be equal to 1 plus R2 over R1. So V out would be equal to 1 plus R2 is 12.4 K and R1 is 2.6 K. All of that multiplied by Vn, which is 3.6 millivolts, gives us 20.76. Oh, did you write it down? Yes. Can I go to the next question? Okay, so for the next question, so in the following question, V out is 150 millivolts, Vn is 5 millivolts, R1 is 6 kilo ohms. Determine the value of R2. Hmm?
98.5.
Yes, that's correct. That was pretty close, by the way. So again, what type of amplifier is this? Non-inverting. So V out over Vn would be 1 plus R2 over R1. V out is 150, Vn is 5. This is equal to 1 plus R2, which is unknown, over 6.5 K. 150 over 5, 30 is equal to 1 plus R2 over 6.5 K. So 29 would be equal to R2 over 6.5 K. Therefore, R2 would be 29 times 6.5 K, which gives us 188.5. So we learned about inverting and non-inverting amplifier. But we have other different types of amplifiers as well. One amplifier that is very commonly used is called a unity amplifier. Imagine that we have let me ask you this. What type of amplifier is this? It's a non-inverting amplifier. So imagine we have a non-inverting amplifier, because here, as you can see, the input is given to the positive input or the non-inverting input. Imagine that we have a non-inverting amplifier, and we reduce R2 to 0, or simply replace it with a short circuit, and R1 with infinity, or in other words, replace it with an open circuit, okay? In the equation for non-inverting amplifier, if I reduce R2 to 0 and R1 to infinite, what this total would be? 0, perfect. Therefore, V out over Vn would be equal to 1, which is called a unity amplifier, or a voltage follower simply. A voltage follower is used as a buffer. The reason that we use it is because we want to separate usually an input from an output. For example, if you are connecting a speaker to a signal amplifier, speakers usually have very low resistance, and if you put a lot of voltage, it's gonna destroy the coil in the speaker. So we use a buffer to separate the input and the output, for example. It has a unity gain of 1, doesn't have any phase shift. So if you give it a signal like this, it's going to give you the exact signal in the output. No phase shift, no voltage gain, nothing. So gain in the system is 1, and the input signal is always equal to the output signal. We also have another type of amplifier, which is called the summing amplifier. Again, can you tell me what type of amplifier is this? Without R2 and R3, imagine that we don't have R2 or R3. We just have one R in the input. What type of amplifier would this be if I don't have inverting? Perfect. Because it's, again, the input is connected to the inverting input. But if I add multiple resistors to the input resistor of an inverting amplifier, then I'm creating then I'm creating a summing amplifier. So as its name suggests, this sums the input and gives this to the output. The output for a summing amplifier, V out, is equal to negative RF over R1 V1 minus RF or negative RF. Let's write it like this: negative RF to R1 V1, negative RF to R2 V2, and negative RF to R3 V3. So as you can see, it's a combination of 3 inverting amplifier, and you just add each input together, and you have a summing amplifier. So it's a summation of 3 inverting amplifier. Yes.
This or all for the equal.
The out, it's going to be negative. So when you mention negative, it's not necessarily less. It means that, for example, if you have an AC signal, you're just going to have a 180 degrees phase shift. You know what I mean? So again, when you have, positive, you're going to have negative in the output and so on. Did you write that down? Let's solve a practice problem with this. So imagine V1 is 50 millivolts. I'm sorry, let's make it 5 millivolts. V2 is 15 millivolts. And V3 is 20 millivolts. RF is 10K. R1 is 2K. R2 is 4K. And R3 is 5K. What is the output voltage be out? Did anyone get the answer? 1.25 millivolts. Oh, 1. Okay. Anyone else has the answer? Yeah. So the equation will be negative RF over R1 times V1 minus RF over R2 V2 minus RF over R3 V3. So the first part, negative 25 millivolts. Second one is gonna be 2.5 times 15 gives us what, 37.5, am I correct? Negative 37.5. And the third part gives us negative 40. So negative 40 plus 25 plus 37 gives us what? 102.5 millivolts. Negative 102.5 millivolts.
Yeah, equals the negative of all the.
Yes, yes. Okay, the next type of amplifier we have is called a difference amplifier. A difference amplifier is a combination between an inverting amplifier and a non-inverting amplifier. And for a difference amplifier, V out would be equal to R2 over R1 V2 minus R2 over R1 V1. So as you can see here, the resistors are equal, and the output voltage R2 over R1 V2 minus R2 over R1 would be equal to this equation. Now let's solve a practice problem for this example, for this type of amplifier. So imagine R2 is 25K and R1 is 1.25K. V1 is 4 millivolts and V2 is 6 millivolts. Calculate V out. So 4 millivolts, 6 millivolts, we want to calculate V out. So V out would be R2 or R1, so 25K or 1.25K times V2, which is 6 millivolts, minus again 25K or 1.25K times 4 millivolts. So 25 over 1.25 is 20. So you're gonna have 20 times 6 is gonna give us 120 millivolts minus 20 times 4, 80 millivolts. So the answer would be 40 millivolts. Now another kind of, let me finish it with this one. I think this is more important. We also have another type, a different type of op amp. if we have a op amp, let's say we have an inverting amplifier. By the way, negative amplifiers or inverting amplifiers are more prevalent, I could say, more used than the other types, but we use different types of amplifiers. One other type of amplifier that we use is an inverting amplifier, but instead of the non-inverting input or the positive input being connected to the ground, it's connected to another voltage source. So the only difference is now here VB is connected to another voltage source. For this type of amplifier, so it's not called an inverting, it's not called an inverting nor a non-inverting amplifier. So for this type of amplifier, V out would be equal to negative R2 over R1 times VA plus 1 plus R2 over R1 VB. Let's solve a practice problem for this one. So imagine R2 is 180K and R1 is 30K. And VA is equal to 5 millivolts and VB is equal to 8 millivolts. We want to calculate V out. What is V out? So again, we can say it's a combination, almost a combination of an inverting and a non-inverting amplifier, but we don't call it a summing amplifier or a difference amplifier. So it's not a difference amplifier, it's a little different. How much? 6, okay. Did anyone else solve it? So V out would be equal to negative 180 over 30 because they both have the same kilo ohm unit. You can just, and they would be divided. So you can just say 180 over 80 times 5. This is millivolts, by the way, plus 1 plus 180 over 30 times 8 millivolts. So 180 over 80 over 30, what does it give us? 6, thank you. So negative 6 times 5 is negative 30 millivolts. 6 plus 7 plus 1, 7 times 8, 56. So negative 30 plus 56 gives us 26 millivolts. Thank you. Okay, so that's it for today. Next week, we're gonna start with offset volt adjustment and other types of operational amplifiers. I was post the second set of homework this weekend, and I'll give you again 10 days to turn that in. The first homework is due, I think, 18th. If you have any questions, just email me about it. Have a great day.